Okay, assuming that I have correctly interpreted this as a multiplication symbol and not x to the first, this is the function we're dealing with. If this really is an x, we'd multiply x to the 2/3 by x to the first, and this would become x to the 5/3, and we'd do a similar thing. But we have to use the product rule to find the derivative. But before we start, let's just look at this graph. This is the graph. This red graph is the graph of the function. It's continuous on the interval from 0 to 1 because we can take the fourth root of a positive number, or 0. And so when x is 1, we do get 1 minus 1. The fourth root of 0 is 0. This green graph is actually the derivative, the graph of the derivative of that function. And you see when it equals 0, we actually get a value of 8/11. And at 8/11 we reach this maximum value because that's where we have a horizontal tangent line. So there's a turning point there. So that's the only critical number for this function on the closed interval from 0 to 1. And we can see that we probably have absolute minimums at both 0 and 1, absolute minimum of 0. Okay, so the question is, how can we figure out this 8/11 here, where the absolute maximum on that interval actually occurs? So we'll apply the product rule. We'll take the derivative of the first function, which is 2/3 x to the minus 1/3, times the second function, which is just 1 minus x to the 1/4, plus the first function times the derivative of the second. So we'll apply the power rule, 1/4 down front, reduce the exponent by 1, or 4/4, becomes negative 3/4. Then we have to apply the chain rule. The derivative of the inside is negative 1. And if we simplify that a little bit, we can rewrite it as on this line right here. Now we want to know, when does that equal 0? So instead of rewriting it, let's just say if I put an equal 0 here, then picture transposing this term that has a minus sign in front of it to the right side of the equal sign. It'll become plus. So this is really what we end up with. The left side equals the right side. Of course, this equal sign's not here anymore. There's the equation we want to solve. And if we multiply both terms by the LCD, which is this, we'll clear the equation of fractions. Or you can actually just visualize cross-multiplying, which is actually pretty easy to see. 4 times 2 is 8. That's this. And 1 minus x to the 1/4 times the quantity 1 minus x to the 3/4 becomes 4/4, which is just a 1. And 3x to the 1/3 times x to the 2/3 just becomes 3x. And you can solve that and see that we get 8/11. And so those are the numbers that we want to test for absolute min and absolute max: 0, 1, and 8/11. So the absolute minimum occurs, again, at both endpoints of the interval, and the absolute max occurs where x is 8/11, a value of 0.5844 approximately. If you want to put 8/11 into the original function, you've got to take the cube root of 8/11 and square it and multiply that by the fourth root of 3/11, which would be an exact value if you wanted to write it that way. Okay, there you go. Hope that helped. If you have any questions, post a comment.